Okay, so we're looking at 2015 SEC Leaving Cert Higher Level Maths Paper 1 Question 4, and it's a complex numbers question. And it's actually, the part B is also a sequences and series question. But if you haven't done sequences and series, I'd ignore part B. And if you've done just complex numbers, maybe just stick with part A. So the question tells us the complex numbers z1, z2, and z3 are such that 2 over z1 is equal to 1 over z2 plus 1 over z3. They tell us what z2 is, and they tell us what z3 is. Okay, they want us to find z1 in rectangular form. So find z1 on its own in rectangular form. So getting z1 on its own. Okay, well, looking at this to begin with, the thing that I don't like, first of all, is all the fractions. So I'm going to actively try and get rid of all the fractions. If you multiply this by z1, you'd just be left with 2. If you multiply this by z1, the z1 is going to come onto the top line, and that's just coming from how we multiply fractions. z1 multiplied by 1 over z2. Well, z1 is the same as z1 over 1, and then how do we multiply fractions? Top by top, bottom by bottom. And that's the exact same logic on what happens to z1 over z3. So I've multiplied everything by z1 to get to this line here. Then I'll multiply everything by z2. So 2 by z2 is 2z2. z1 over z2 by z2 is just z1. z1 over z3 by z2. So that's kind of going z2 times z1 over z3. That's z2 over 1, top by top, bottom by bottom, and that's how we get to this line. Then we want to get rid of the z3 on the bottom line, so we're multiplying everything by z3, which gives us 2z2 z3 plus z1 z3 plus z1 over z2. Because again, we're multiplying by z3 to get rid of the fraction, so you'd just be left with the top line. Eyes on the prize now. What do you want to get on its own? You want to get z1 on its own. You want to get z1 on its own, so I will factorize out the z1. I want to get this on its own, but it's being multiplied by z3 plus z2. So if I divide both sides by z3 plus z2, I will get z1 on its own. And now I can sub in what I know z2 and z3 are. If you sub in what we know what z2 and z3 are, to get to here, we just need to actively go and multiply it out. The bottom line is 3 plus 2, which is 5, and 3i minus 2i, which is 1i. On the top line, I've multiplied out the two brackets, so 2 by 3 is 6, 2 by minus 2 is 2 by minus 2i is minus 4i, 3i by 3 is 9i, plus by minus is minus, 3 by 2 is 6, I by I is I squared. We know that 6i squared is really plus 6, that minus 6i squared is really plus 6, so it's plus 6 and plus 6 gives us 12. And we know the minus 4i, I'll just delete it, minus 4i and plus 9i gives plus 5i. Then we just need to multiply in by the 2. So 24 plus 10i over 5 plus I. Okay, well, how do I deal with division in complex numbers? The only thing I can multiply this by is the number 1. But I know the number 1 can be written as 1 over 1, or 2 over 2, or x over x. And also it could be written as 5 minus I over 5 minus I. So I'm multiplying top and bottom by the conjugate of the bottom. How do we multiply fractions then? We go top by top, bottom by bottom. With multiplying the bottoms together, you should remember that multiplying a complex number by its conjugate, we can use that little shortcut here. That if it's a plus bi by a minus bi, it's just a squared plus b squared. Top lines get brought together as if they're two brackets, because they are two brackets. They're two numbers in and of themselves. and we slowly multiply them together. 24 by 5 is 120, 24 by minus I is minus 24i, 10i by 5 is 50i, 10i by minus I is minus 10i squared, and we know that this is really plus 10 because the I squared is minus 1. Remember? I squared is equal to minus 1. And simplify the question down. 26 divides into 130 5 times, 26 divides into 26i 1i times. Actually a lovely question for 15 marks. Just haven't talked through it. It's taken just under, or just around 5 minutes for 15 marks. Quite a lovely question. So it's 0, 4, 7, 11, 15. Not so much complex numbers, bar this bit, I suppose, multiplying top and bottom by the bottom conjugate of the bottom. It's really a algebra question, very algebra heavy. The next part, B, as I said, if you haven't done sequences and series, don't worry about this question. If you haven't done sequences and series, don't worry about it. Just go on to the next video or go on to the next question, whatever you're working on. If you have done sequences and series, it's a lovely question. So let omega be a complex number such that omega to the power of n is equal to 1. Okay, that's an important one. And S, that's the sum of 1 plus omega squared plus dot 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 plus omega to the power, or omega to the power of n minus 1. Use the formula for the sum of a finite geometric series. Okay, so this is what it's looking at. Ooh, not black. A finite geometric series is here from the log tables, where we know a is equal to the first term. Okay, well a is then 1, our first term. See, I said first above it, second above omega, third above omega squared, and compare the powers, 3 and 2, 2 and 1. So if this is n minus 1, this is going to be the nth term. So that tells you how many terms there are as well. How many terms there are is coming from here. There are n terms, and then the common ratio is or, but in this case it's going to be omega. Common ratio is what do I multiply the first term by to get to the second term. 1 by omega is omega. What do I multiply the second term by to get to the third term? Would be omega. And it's also Tn, or is equal to Tn over Tn minus 1. So that could be term 3 over term 2, or term 2 over term 1, whatever. We're filling into our formula then. So I know A is 1. I know 1 minus omega to the power of n. And I want to write this in its simplest form. Okay, well, do I need this 1 on the outside here multiplying by 1? No, not really, so I can just get rid of it. What do I know about omega to the power of n? Omega to the power of n. From here, omega to the power of n is 1. So on the top line I have 1 minus 1, which gives 0. And then anything divided by, 0 divided by anything is 0. So the final answer is 0. The sum, it adds up to 0. So 0, 4, 7, 10 marks. If you've done sequences and series, it's a really, really nice question because it's quite straightforward, and just fill into the formula that is given to you in the log tables. Okay, hopefully you found the video useful anyways.